Okay. So I need everyone to have their notes out. And it's already up on the board, so you should start copying down the objective. Today we're going to be working with exponential graphs. And actually in my other classes we didn't even make it to exponential graphs, so this might bridge over 2 days. Because we're going to review all the graphs we know how to graph. So our goal today is to find horizontal and vertical shift and a stretch, shrink, or neither for an exponential function. Guys, I need everyone to quiet down now. We are ready. So, hopefully these terms sound familiar to you. We've talked about horizontal and vertical shift before when we were working with quadratics. We've talked about stretch, shrink, or neither when we were working with quadratics. So we're going to review how to graph the two types of functions we already know how to graph, a line and a quadratic. Quadratics we've done this year, lines you should have learned last year. And then if we have time, we'll talk about how to graph an exponential function, which you've also probably seen before, but now we're going to graph them in a little greater detail. You should have seen them in your math class last year. I'm 100% sure you did, but you should have. So today we're going to start with a line. We're going to start by reviewing to graph a line. And in the past, you always just identified slope and y-intercept. We're going to start calling those by different names because then you'll see the connection between how we graph a line, how we graph a quadratic, how we graph an exponential function. They're all basically the same thing when you actually perform the graphing. It just starts with a different shape, but they're all graphed basically the same way. So we know when we're working with a line, the equation for a line is y equals mx plus b. That should look very, very familiar. What did we usually call m? Slope. And what did we usually call b? Y-intercept. So the most basic form is just the one that has that first variable, x. So y equals x is called our parent function. So we draw, it's basically a 45-degree line. It should go exactly through the center. There we go. There's our parent function. We know the slope is up 1 over 1. We know it starts in the center, so we start here. And our slope is up 1 over 1. So all the rest of the lines we graph are based on this parent function. This parent function, we basically just move it around or tilt it to draw any other line. Just like with our quadratics, we just move it around and stretch it or shrink it to draw another quadratic. So I want you guys to get out your calculators now. Does everyone have this written down before I go to the software? I'll give you a second to write it down. Again, if you want to use your own 83 or 84, that's fine. We just need something that will graph. I'm going to get the software to start booting because I forgot to do that earlier. Hopefully it's booting. Okay, I better double check. Yeah, it is booting. Okay, so while that's booting, if you haven't finished writing this down, you can. So on the Inspires, to get to a graphing page, you're going to still hit the scratch pad button. You're just going to hit it twice. So you're going to hit the scratch pad button and it should come up to your calculator page.
What was that?
You're going to hit your scratch pad button, the button under the escape key. It doesn't actually label it as scratch pad, but it's called scratch pad. You will push that and it'll come up with the calculator. And if you push it again, it'll go to the graphing. And you just push it to go back and forth between calculator and graphing. If you already have graphs from other classes, just hit Doc B. Doc is on the far right. Doc. B. Doc and then the letter B. Okay? Yeah, you should be able to hit Doc and then B. It'll erase everything, and then you might have to hit the scratch pad button again to get to the graph. Doc B. So your graph should be showing at the bottom. We just got a software update, and I still need to update all the calculators. Your graph should show at the bottom. If it is not showing f of x, hit the tab button, and it'll show f of x for you. And first, we're just going to graph that parent function. We're going to graph the parent function. Now, on this calculator, we can actually grab the parent function and move it around. So what you're going to do is you're going to use your mouse here to, this one is much harder. It's much harder on the smartboard. So if you get these rotating arrow things, that's not what we want right now. So we don't want the rotating arrows, although I've got to get my graph back to 1x. Come on. Close enough. What we want is, okay, you want the moving arrows, so it just looks like its own coordinate system. Once you get that on the line, if you hold down, come on.
The line first. Yeah, what line? You don't need that.
Oh, I told you guys to graph the line that's just x. So just type. This new software update is not my favorite because it keeps doing that. Okay. Yeah, just type in x and then hit enter. I'm going to escape out of this because it's being crazy. If it's not showing, hit tab. Tab will make the f of x show up. Okay? So, you want the moving arrows to show up, and then if you hold down, it's not showing it on the board, but if you hold down, a hand should pop up and clamp down. Once the hand is clamped down, you can release the mouse. You don't have to hold it down after the hand is clamped down. And once you do that, you should be able to hit the up and down arrows, and it'll move the graph. Okay. So while you're moving the graph, I want you to only move the graph up and down. I want you to watch what happens to the equation, because it shows you the equation on the screen. Okay, so I heard someone say, okay, Kyle made a conjecture already. What did you say, Kyle? Okay, he said it's adding. So if we move it up, okay. If we move it up, it starts adding. What if we move it down? It starts subtracting. Okay. So if we're moving it up and we're moving it down, what kind of movement is that? What would we call an up and down direction? Okay, horizontal is left and right. The way I remember horizontal, my brother taught me this. I still remember. When you look at the horizon, like when you're watching a sunset, the earth looks like it's flat, horizontally. You don't have the sunset going this way and hitting, land on the left and sunset on the right. So horizontal is left to right. So that means we made a vertical movement. And in fact, we call that a vertical shift. So, what number then in this equation, y equals mx plus b, would we consider to be our vertical shift? We moved our graph vertically, and what number did it change when we moved our graph vertically? B. Okay. So B is our vertical shift. So you guys should write down that B is your vertical shift in your notes. I know we're working back and forth between the calculator, but you do need to write that B is the vertical shift in your notes. In the past, we called that the y-intercept. Now, I didn't address this with every class, but what happens when we move our graph horizontally? So if I go back to the beginning, actually, well, I don't think I can change it up here. What happens if we move our graph horizontally? What's changing as we move our graph from left to right? So the positive side is actually minusing. Okay? So when you move a line horizontally, quadratics, it really changes things. But when you move a line, it's still considering this as a vertical shift because it's still considering just where your line is crossing the y-axis. Notice that number is still where we cross the y-axis. So even though it's changing that number still on the right, it's still looking at where it's crossing the y-axis. So with a line, we actually don't really ever consider that we have a horizontal shift. So with a line, it only ever has a vertical shift. So there is no horizontal shift.
Under the B plus, is it a V5?
What?
Under B, is it a V5?
No, it's a VS for vertical shift. Sorry. So, we never consider a line to have a horizontal shift because it doesn't change really when you move it to the left and right. It's still considering what's going on the y-axis. So next, let's see what happens when we change our slope. This time we're going to graph a couple of lines if my software will allow me to. It's kind of freaking out when I try and graph something else. So, we want our line back in the center, which means I want to change this back to just plain old x. So if you hit the tab button, and I think mine's going to freak out when I do this. Why? If you hit the tab button, yours will come up on the bottom, and it will have an arrow on the bottom right. So the arrow on the bottom right, if you click that, then you can select F of 1 again and change. There we go. Stay. No, come on. I don't know what is wrong with this new update, but it's pissing me off. Okay. So we just want X right now to show on our board. I'm going to have to draw the rest by hand because this software is freaking out. So if we change that number in front, let's try like 3x. So now you're going to hit the tab button again. I cannot show you again on the smartboard because this new software update is freaking out. I'm going to have to email TI. So if you hit the tab button, it'll give you an F of 2 on the bottom, and you're going to enter in 3x. So you'll have two lines, one like this, one, oh, there we go, one like that. So when you have your two lines, what changed? You need to enter in 2x, so you have two lines. What changed when we made that a positive? I said 3x. What changed when we made that a positive x? How did that line change? The slope got steeper. How can I get a line that was even steeper than I had already? 4x. Okay, let's do 4x. So, if I enter in 4x, so again, you'd have to hit tab one more time. Ooh, maybe it'll let me do it. Woo!
Wait, what was the first equation you did?
The first equation is just x.
Okay, the second.
The second one was 3x. And the next one is 4x. So, what direction are we tilting as we increase our slope?
This way.
Okay? So, vertically, we're going towards the y-axis. We are rotating that way. We call that our stretch. When we move towards the y-axis, it's called a stretch. What do you think I would have to do to make it a shrink? How could I get a line below towards closer to the x-axis?
Negative.
Okay? So let's try it. Try a negative x. Try typing a negative x, hitting enter. Okay? It flipped it the other way. Did we get any closer to the x-axis? No, we didn't. This is still from here to here. That's the same as from here to here. It's the opposite direction, but it's still the same distance. So that didn't do what we wanted it to. We wanted it to get closer to the x-axis. So what's a different idea? We tried negative, and negative didn't do what we wanted it to.
X plus 3.
Okay? Okay? What did we say the plus 3 is going to do, though?
Still put it.
It's going to just move our graph up and down. Okay? We have to do something with the m. The m is the one that changes. Okay? We've tried whole numbers, we've tried negatives. Now Jade says, let's try a fraction. So let's try it. Jenny? So let's try a fraction. Let's try 1 divided by 2, x. Did that get closer to the x-axis?
Yes.
Yes. So that did what we wanted it to. Okay. It rotated it towards the x-axis. So when we rotate towards the y-axis, it's called a stretch. Guys, I hear a lot of chatting. I need your attention up front right now. Okay. When it rotated towards the y-axis, what kind of numbers made it rotate towards the y-axis? Whole numbers. Okay. What kind of numbers made it rotate to the x-axis? Fractions. Okay. So that gives us a new set of rules for our slope. We need to be more specific with our slope now and what it's doing. We call moving towards the y-axis a stretch. It's a stretch when we move towards y-axis. And specifically, because it's going to give us a number in front of the x, we can look at that number and decide if it's going to stretch it or shrink it, because we said our slope has to be bigger than 1. We had whole numbers bigger than 1. In fact, fractions bigger than 1 would have worked as well. If I did 5 halves, 5 halves is 2.5. That would still make my slope steeper. So it's any number bigger than 1, not just whole numbers bigger than 1. If it's 1 itself, we're just going to get that parent graph that goes with the slope of 1 over 1. So what was our second option? What did we say happens when we go towards the x-axis? What did I call that? A shrink. Okay. So we get a shrink if we move towards x-axis. I guess I should say rotate, not moves. If you've already written moves, that's fine, but really the more appropriate word would be rotate. Rotates towards the x-axis, rotates towards the y-axis. And that happened when we were between 0 and 1, when we had those fractions that are smaller than 1. And then what happened when we were negative? That did something completely different than what we expected. It flipped it. So m is a flip if negative. And I just realized I forgot to include neither. I really should have done neither before flip, so it was grouped a little bit nicer, but it's neither if m equals 1. So when we graph our line, we're still going to graph it the same way. We're still going to find where to start. We're going to still find the slope. We're just calling them by different things because it'll relate to the quadratics we're graphing. It'll relate to the exponential functions we're graphing. So we are going to do an example, and then I'm going to have you guys try one where you label everything that we've talked about. So our example is y equals negative 2x minus 3. Y equals negative 2x minus 3. So when we do these, we're going to have a graph. The graph will be given to you on the homework. And then you're going to have to write in the horizontal shift, the vertical shift, if it flips or not, stretch, shrink, or neither. And then you're going to have to identify which type of graph you're working with, linear, quadratic, or exponential. I wrote it in once on the assignment. The rest of the time you're going to have to write it in yourself. But I wrote it on the assignment once to give you what I wanted for each graphing problem. So Kyle was the first one to notice which number tells us our vertical shift. So of the two numbers written there, which one changed when we dragged our graph up and down? The negative 3. So that is our vertical shift, and when we went down, it was negative. When we went up, it was positive. So this number tells us our vertical shift, and it tells us to go down 3. And I literally want you to either write the words down, or you could write a down arrow and 3. But on like an acuity or a SAGE test, they're going to use the words vertical shift down 3, something like that. So that's why I want you to show a direction. What did we say happens with a horizontal shift on a line? Okay, horizontal shift. I heard a lot of whispered answers, and I didn't really hear what anyone said. What do you think? Okay, you're thinking of when we had a quadratic. A line has a special thing going on with horizontal shift. That is our tilt. That has to do with our stretch, shrink, or neither. Okay, so let's scroll back up and see what we said, and hopefully you wrote it down in your notes. What did we say about horizontal shift for a line? There is no horizontal shift for a line. It's not considered a horizontal shift because a line retains the same shape whether you move it left or right or up or down. And so they still are just looking at where the line crosses the y-axis. So our horizontal shift, if it's a line, is none. We have no horizontal shift when it's a line. Okay, so we've used the negative 3. Now we're going to be looking at the negative 2, and it's going to tell us the next two things. The negative 2, what about the negative 2 tells us if we have a flip or not? Okay. It is a flip because the negative. So this negative sign tells us if we flip. So yes, we flip. And then the number 2 itself without the negative sign tells us if we have a stretch, shrink, or neither. Okay. Okay, I heard 2 answers. I heard one person say shrink, one person say stretch. If you think it's a shrink, hold up a 1. If you think it's a stretch, hold up a 2. Shrink, a 1. Stretch, a 2. I should see everyone voting. Ruben and Danny, I need you to vote. Kyle and Chris, I need you to vote. Shrink, if you think it's a shrink, hold up a 1. Stretch, hold up a 2. Okay, we're still getting mixed answers. So again, let's scroll up and check. How do we know if it's a stretch? Okay, it moves towards the y-axis and the number is bigger than 1. It's a shrink if it moves towards the x-axis and the number is between 0 and 1. So that's how we know if it's a stretch or a shrink. So let's take a revote now and see if we can get more agreement. 1 if you think this will give you a stretch. No, sorry. 1 if you think it will give you a shrink, because that's what we said last time. 2 if you think it will give you a stretch. So 1 or 2. We need everyone to vote so we can see if we have more agreement now or if we're still disagreeing as a class. Okay. So I did see a couple of the people who have 1s changed to a 2. We have more agreement than we did. This is a stretch. 2 is bigger than 1. We are ignoring the negative sign. Yes, negative 2 is less than 1, but we do not consider the negative sign when we decide if it's a stretch or a shrink. So since 2 is bigger than 1, we have a stretch. And if you went to go graph your line, it would move towards the y-axis. Okay. So then, we've only worked with lines so far, so we definitely know it's linear. A linear function will have just an x. Quadratic will have just an x squared, or when I say just, it will have at most an x. So we can't have an x squared and be a line. Quadratic will have an x squared. We couldn't have x cubed. Exponential will have x as an exponent. Okay, it's completely different than the other two. So now, let's graph our line. So, if we had our parent function, it would look like this. And we said this parent function is going to move down 3. So when we do this, we always just start from the center. From the center, I'm going to count down 3. And that'll be moving towards our new graph. Our new graph, so far all we've done is move it down 3. But we also said it has a stretch. It's going to move towards the y-axis, and it has a flip. It's going to move upside down. So if it stretched 2, we would go up 2 over 1, and it would look like this. And really, we just need the final one. I'm just showing you how these are actually moving the line itself. So then the final one, we would say, let's flip this. If we flip it, it goes like this. So all we really did was go from the center, count down 3, and then we know our slope is negative 2 over 1 because we always make it a fraction. So we counted down 2 over 1. But we're trying to also make the connection that really we took that original line and we moved it around. We moved it down first, we stretched it toward the y-axis, and then we flipped it. So we're really doing all these movements to get this last graph. So when you do your try problem, you can just draw the final graph. You don't have to draw all the movements. I'm just trying to get you to connect that, hey, these lines are actually moving from that original line. So I want you to try one. I'm going to give you about 5 minutes. I want you to try, make sure you identify horizontal shift, vertical shift, if it flips or not, if there's a stretch, shrink, or neither, and if it's linear, quadratic, or exponential. Okay, so I had you guys write up on the board all the information you should have gotten for the try problem. Horizontal shift is always none for a line. Vertical shift is up 4. It did not flip, no, because it's a positive, not a negative. It was a shrink because it was a fraction. We're still only working with lines, so right now we know it's linear because that's all we're working with. And then it said go up 4, so from the center we counted up 4. And then we used this number to tell us the slope. From here we went up 1, right 3, and drew our straight line. Okay. So again, it's all stuff you've seen before, but it's just named differently. So next, we also talked about how to graph a quadratic. So we're going to review how to graph a quadratic again. We're probably not even going to make it to exponentials today. This will go over 2 days. Mayela? Yes. So let's review how we graph a quadratic. So the quadratic equation I gave you is y equals a times x minus h squared plus k. We haven't seen this form for a while. What form did we call that? So the quadratic equation I gave you is y equals a times x minus h squared plus k. And it had a special name. We learned it a while ago when we were doing graphing. The one we've been working with more often is standard form, where it's just the ax squared plus bx plus c. This one was vertex form. Jade said, hey, this is called vertex form. So this will have some of the same movements as a line. This is very similar to what we did with a line. The very last number on a line told us our vertical shift. So which one of these tells us our vertical shift? The A, the H, or the K? The K. The very last one, just like on a line, the very last number told us our vertical shift. On a quadratic, it's the same thing. This is our vertical shift. What number on a line told us if we stretch, shrink, or neither? Is H in the same spot as before? It was M on a line. It was mx plus b. So it's going to be the A. The number in front of x is like M on a line. It tells us if we stretch, shrink, or neither. So A tells us if we stretch, and we stretch with the same exact reasoning as a line. Stretch if A is bigger than 1. We shrink if A is between 0 and 1. Neither if A equals 1. And we flip if A is negative. So it's the exact same reasoning as a line. We're going to start with a different shape. We know a quadratic does not look like a line. We know a line, it's just the straight line. What shape did a quadratic make? It had a special shape. Looks like a letter of the alphabet. What shape?
The U.
Makes a U shape. It also had a special name, just like we named a circle. That shape, something that's round is called a circle. Something that has 4 sides is called a square. That U shape had its own special name.
U.
Okay. Anyone remember what the U shape was called for? Parabola. And then Mackenzie, did you have a question? Okay. Okay, so the U shape is called a parabola. So again, we need our parent function, and actually before I graph the parent function, let's discuss what h will do. Before we didn't have an h, we didn't have parentheses involved when we had a line. This time we do have parentheses and we have that h inside. So I didn't try this with the other classes. We're going to see how it works out. Go ahead and get your calculator out again. I'm not sure if it'll show it the way I want it to be shown. Clear out everything, just hit Doc B and it'll clear out everything.
I didn't do that one.
And let's graph in parentheses x, let's do -1 squared. Now, the parent function starts in the middle. If we do x minus 1 squared, what direction will the parent function slide? Okay? So I heard two answers, to the left and to the right. Let's check. If we hit enter, it actually moved to the right. Our parent function always starts in the center, that slid to the right. How could I get it even further right? What equation would I use to get it further right? X minus 3. Vincent said, let's do x minus 3. So if you hit tab, okay, it's not freaking out, parenthesis, x minus 3 and parentheses squared. We slid it even further right. Okay. How could I slide it to the left? X plus 3. So if we hit tab again, parenthesis, oh, I hit y instead of x, backspace. X plus 3, we do need the squared or else it'll give you a line, not a parabola. I did forget to say squared. It must be squared.
Very first line, teacher.
The very first one is x minus 1. The second one we did x minus 3 squared. Sorry, x minus 1 squared. X minus 3 squared. Then we tried x plus 3 squared. Oh, why am I on f of 2 again? I'm going to have to do it again. X plus 3 squared. Okay, so what direction did we slide that time? To the left. So, that number inside the parentheses moves our graph left and right. Let's see. What? Yep. What would happen if we move it up and down? What's going to change? Stop.
There'll be a minus on that.
I know. Ah, and now it flipped. Come on. Doc B. Okay, let's try this again. If we move it left or right, really? It's moving, it's stretching it and shrinking it, and I want it to move. There we go. Okay, if I move it left or right, this number inside the parenthesis changes. I'm going to move the label out of the way. What's changing when I move it up or down?
The outside number is more small.
The outside number is changing. So if you move it left or right, the inside number is changing. If you move it up or down, the outside number is changing. So that's why we call them vertical shift and horizontal shift, because they change different things. So H is our horizontal shift.
Can you leave that there?
Yeah, I think we're done with the calculator for today. We're just doing the rest of this information and then an example. Not yet, because then people will also want to pack up their notes. Not yet. Okay, and horizontal shift, positive actually moved left, thank you. Negative moved to the right. It's opposite of what we expect when it's inside. Again, this should hopefully sound familiar. At the end of first quarter, we did a lot of graphing of quadratics. So then, the other information we need to know is the pattern the quadratic follows. If I go right 1, and I plug in 1 for x, what am I going to get for y? If I plug in 1 for x, it's telling me to do 1 squared, so what would y be? 1. 1 squared is 1. So if I go right 1, it tells me to go up 1. Same thing if I plugged in negative 1. Negative 1 goes up 1. What would happen if I plugged in 2? Goes up 4. So to make it similar to a line, we put it in kind of a slope format because we know slope is rise over run. So what did we call the slope of a quadratic? Or what did we use every time for the slope of a quadratic? 1 over 1, 4 over 2. Now that's just a pattern we follow so that we can graph it a little bit easier. It's our pattern we can follow to graph this quadratic. So we're going to just do one last example and then I'll pass out the assignment. You'll have about 10 minutes, so you will need to get started on the assignment. Okay, so the example will be y equals negative 2, x plus 1 squared plus 3. I'm not scrolling all the way down yet because I want people to be able to finish writing the stuff up above if they need to. Chris, you should be writing the example down. So, even though we're graphing a completely different shape, we are still going to name the same things. We're going to still name horizontal shift. We're still going to name vertical shift. We're still going to name if it flips or not. We're still going to name if it has a stretch, shrink, or neither. And we're still going to name if it's a linear, quadratic, or exponential. We're still naming the same things. We're just starting with a different shape because the squared changes what kind of shape you get. Exponential will be the same way. When we get to exponential, we still just name all the same things, but we start with a different shape. So, when we're looking at this, what number did we say was our vertical shift? Let's start with the vertical shift. We have
3.
the plus 3. It's the very last one. Just like on a line, it was the very last number. So we go up 3. Because it's positive, we go up. We use a different color so it's different than the labels. Okay, then what number did we just work with to discover our horizontal shifts? The 1. And if it's positive, what direction do we go? Left. Left is that way for you guys. I'm always backwards up at the board. Left 1. Flip. Flip is the same idea. Is there a negative in front of everything?
Yes.
Yes. So yes, we have a flip. Again, stretch, shrink, or neither. We're still just looking at this number in front, 2. Does 2 tell us if we have a stretch, shrink, or neither? Stretch. And then, because there is a squared, we know it's a quadratic. When it's squared, we know we're working with a quadratic or parabola. So now we just have to graph this. So something else you may have to write down, but I'm not going to make you, is the slope. Normally the slope is 1 over 1, 4 over 2. But we talked about how this number in front changes that. We have to multiply the top numbers by negative 2. So our slope would be negative 2 over 1, negative 8 over 2. So again, you don't have to write the slope down. If you can do that in your head, you don't need to write it down anymore. Yep, and the vertex is really just your horizontal and vertical shift. So we go left 1, up 3, and that's where our quadraticals start. Those tell us where to start our picture. And then the stretch and the flip tells us where to go from there, but we've been thinking of it as the slope, negative 2 over 1, negative 8 over 2. We know the shape of a quadratic is a U, so we know it has to repeat on both sides. We know we go down 2, right 1, and also down 2, left 1. It has to repeat to get that U shape. Then from the center we go down 8 over 2, down 8, left 2. So again, this is a vertical stretch because it pulled it in from its original shape. Originally it was a nice U. Now it's pulled in and it's kind of a stretched out U. So on your homework, I have not told you which ones are linear and which ones are quadratic and which ones are exponential. That's part of what I want you to do is you have to go through, and we didn't graph exponentials, so you just have to find only the linear functions, only the quadratic functions, and graph those.